There's a hidden side to the universe, one that cannot be seen, touched, or even comprehended by human senses. What if everything known about reality is just a small part of something much larger, something beyond human perception? Scientists believe our universe may contain hidden dimensions, extra layers of reality that could change everything understood about physics, gravity, and even the nature of existence itself. These dimensions, if they exist, might be the missing pieces that explain the deepest mysteries of the cosmos. They could answer questions that have puzzled scientists for centuries, revealing an unseen architecture of the universe that governs the way everything in existence interacts. In everyday life, space is experienced in 3 dimensions: length, width, and height. Time adds a 4th dimension, creating the fabric of spacetime as described by Einstein's theory of relativity. But many physicists believe these 4 dimensions are only part of the picture. Theoretical models suggest that the universe could have many more, possibly 10, 11, or even more dimensions folded into the structure of reality itself. If true, these hidden dimensions could explain phenomena that have baffled scientists for decades, from the nature of gravity to the strange behavior of subatomic particles. Some researchers believe that these extra dimensions could be a gateway to understanding forces that currently defy explanation, such as dark energy, the mysterious force that causes the universe to expand at an accelerating rate. One of the most compelling theories proposing extra dimensions is string theory. According to this idea, everything in the universe is made up of tiny, vibrating strings rather than point-like particles. These strings don't just vibrate in the familiar 3-dimensional space, they may oscillate within unseen dimensions, shaping the fundamental properties of everything in existence. The vibrations of these strings determine the nature of particles, whether they manifest as electrons, quarks, or even force-carrying particles like photons and gluons. But if these extra dimensions are real, why can't they be observed? The answer might lie in their size. Imagine an ant crawling along a thin wire. To the ant, the wire appears one-dimensional, stretching forward and backward. However, from a wider perspective, the wire has depth and width. Scientists propose that hidden dimensions might be compactified in a similar way, curled up so small that they are undetectable with current technology. These dimensions, known as Calabi-Yau spaces, might be smaller than the Planck length, making them impossible to probe directly with existing instruments. Gravity, the force governing planets, stars, and galaxies, might hold the key to detecting these hidden dimensions. Compared to other fundamental forces like electromagnetism, gravity is incredibly weak. The electromagnetic force is strong enough to hold a magnet to a refrigerator despite the entire Earth's gravitational pull acting against it. Some physicists theorize that gravity's weakness could be due to it leaking into extra dimensions. If true, it would suggest that gravity is not confined to the 4-dimensional universe but is spreading into other layers of reality. This could explain why it appears so much weaker than other forces and could offer a new perspective on why the universe behaves the way it does. Some scientists have proposed experiments to test this idea, including measurements of gravitational attraction at extremely small distances to detect possible deviations from Newton's laws. If extra dimensions exist, then at microscopic scales, gravity might behave in a way that cannot be explained by standard physics. Dark matter, the mysterious substance making up most of the universe's mass, might also be linked to hidden dimensions. Despite its invisibility, dark matter has a profound gravitational effect, shaping galaxies and cosmic structures. Some theories suggest that dark matter isn't a new type of particle, but rather ordinary matter trapped in a parallel dimension, interacting with this universe only through gravity. If this is true, then what is perceived as dark matter might actually be a reflection of matter existing in another realm of spacetime. This would mean that galaxies might not only be shaped by the matter we can see, but also by the gravitational effects of matter hidden in another dimension. If this is true, then the discovery of these extra dimensions would revolutionize our understanding of cosmology and astrophysics. The possibility of hidden dimensions raises even more mind-blowing questions. If extra dimensions exist, could they be home to entire parallel universes? Some theories suggest that each hidden dimension might contain a different version of reality, where the laws of physics vary, where time flows differently, and where alternate versions of events unfold. Every decision made, every quantum fluctuation, could result in a different universe emerging within these unseen dimensions. This is the basis of some interpretations of the multiverse hypothesis, where infinite versions of reality coexist, each shaped by slight variations in fundamental physical laws. If this is true, then the universe as it is known is just one of countless realities coexisting in a vast multiverse. Some physicists have even speculated that our consciousness itself might be influenced by these hidden dimensions, raising questions about the nature of free will, reality, and existence itself.
Beyond theoretical physics, the practical implications of extra dimensions could be revolutionary. If higher dimensions can be manipulated, could faster-than-light travel become possible? Could advanced civilizations have already discovered ways to access these realms, using interdimensional shortcuts to traverse the cosmos? The concept of a warp drive, a staple of science fiction, might not be entirely impossible if extra dimensions provide a way to bend space-time beyond our current understanding. Some researchers speculate that wormholes, hypothetical bridges connecting distant points in space, could exist due to the presence of extra dimensions. If such pathways could be controlled, they might allow near-instantaneous travel across the universe. Could time itself be nothing more than another dimension waiting to be controlled? These ideas, once confined to science fiction, are now serious topics of discussion among some of the greatest scientific minds. Experiments are already underway to find evidence of hidden dimensions. The Large Hadron Collider, the most powerful particle accelerator on Earth, is probing the deepest layers of reality, searching for particles that might hint at the existence of extra dimensions. Some theories predict that the LHC might create microscopic black holes, which would be a strong sign that gravity is interacting with hidden dimensions. If these dimensions are real, their discovery could change physics forever, rewriting textbooks and redefining humanity's understanding of space and time. Other experiments, including those studying cosmic microwave background radiation and gravitational waves, could provide additional clues that extra dimensions exist. If the structure of space-time is far more complex than previously thought, the implications could stretch far beyond physics, impacting fields like quantum computing, energy production, and even consciousness studies. The hidden dimensions of the universe may hold the answers to some of the greatest mysteries of existence. If proven, they could unlock new realms of knowledge and technology beyond imagination. Could these dimensions explain the origins of the universe? Could they provide a deeper understanding of consciousness and reality itself? The search for hidden dimensions is more than a scientific endeavor, it is a quest to uncover the true nature of the cosmos. If the universe is far bigger and more complex than currently understood, then the journey to explore these dimensions may only be beginning. Perhaps the key to unlocking the universe's deepest secrets lies just beyond the limits of human perception, waiting to be discovered.